June 6, 1944. Dawn breaks over the beaches of Normandy, a tide of humanity and steel crashing onto a continent held captive. The initial hours of D-Day, the daring scramble from landing craft onto hostile shores, would etch themselves into history as a testament to courage and meticulous planning. But even as the first waves fought their way inland, a far greater, more insidious challenge loomed, threatening to strangle the entire operation before it could truly begin: logistics. The monumental task of merely getting ashore was quickly to be dwarfed by the staggering logistical demand of staying ashore, and then critically, advancing. The Allied High Command knew with chilling certainty that the success or failure of Operation Overlord hinged not just on breaking through the Atlantic Wall, but on sustaining the immense fighting machine that followed. Hundreds of thousands of men, tanks, weighing upwards of 60 tons, self-propelled artillery jeeps, trucks, mountains of ammunition, millions of gallons of fuel, food, medical supplies, spare parts for every conceivable piece of equipment. All of it and more had to be poured onto French soil relentlessly, day after day, week after week. This wasn't just about moving supplies. It was about creating a continuous, overwhelming torrent of material that would allow the Allies to outfight, outmaneuver, and ultimately overwhelm the Wehrmacht. Normandy presented a formidable problem. Its coastline, a mix of sandy beaches, rocky outcrops, and tidal flats, was ill-suited for large-scale port operations. The handful of natural deep-water ports, such as Cherbourg and Le Havre, were heavily fortified, expected to be defended to the last man, and almost certainly rigged for demolition. The Germans, understanding the critical importance of ports, had prepared a scorched earth policy, ready to destroy dock facilities, crane installations, and anything else that could aid an invader, even if captured relatively intact. Repairing such destruction would take weeks, if not months. Precious time the Allies simply did not have. The initial strategy relied on beach landings, using specialized landing craft like the LSTs, landing ship, tank, which could beach themselves and offload directly onto the sand. But this was a bottleneck waiting to happen. Beaches are exposed, vulnerable to weather, and inherently inefficient for the volume required. A single storm could close down beach operations for days, halting the flow of vital supplies and leaving the invasion force stranded, starved of the very resources needed to fight. Ships would have to wait offshore, cargo stagnating, while German U-boats and aircraft hunted them. The thought of thousands of men stranded on a hostile beachhead without fuel for their tanks or shells for their guns was a nightmare scenario that haunted every planner. The mathematical calculations were stark and unforgiving. To maintain the advance, to push beyond the beachhead and break out into the French countryside, the Allied forces would need to land an average of at least 12,000 tons of supplies daily, alongside tens of thousands of vehicles and personnel. This figure would only increase as the front expanded. Traditional methods were utterly inadequate. The sheer number of ships and the need for rapid turnaround demanded fully functioning, protected port facilities, the kind that simply didn't exist in the proposed invasion area. This wasn't a secondary consideration. It was the absolute core of the entire operation. Without a reliable, high-volume supply chain, D-Day would inevitably fail, becoming a tragic footnote in history rather than its turning point. The initial landings were just the opening acts. The ability to supply the follow-up forces, to keep them armed, fueled, and fed, was the defining challenge. It necessitated a solution so audacious, so unprecedented, that it bordered on fantasy: the creation of fully functional artificial harbors designed to float across the English Channel and be assembled on the Normandy coast. A logistical problem of unparalleled magnitude demanded an engineering marvel of similar scale, one that would make the impossible possible. May 30th, 1942, deep within the clandestine war rooms of Whitehall, London, the audacious concept of an artificial harbor began its improbable journey from abstract idea to concrete reality. The necessity for such a contrivance had festered in the minds of strategists for months. Ever since the grim lessons of Dieppe starkly illustrated the suicidal cost of seizing an existing port from determined enemy hands, the alternative was a direct assault on unfortified beaches. Yet without a harbor, how could an army sustain itself? It was a logistical paradox that demanded a leap of faith into the realm of the unthinkable. Winston Churchill, ever the visionary with a penchant for the grand and the unconventional, was perhaps the first to articulate the solution with characteristic bluntness. In a now famous memo, he scrawled, "Piers for use on beaches," adding that these must be across which traffic can flow, including tanks, at the rate of thousands of tons a day. He further specified the need for sheltered water, suggesting the construction of floating breakwaters. This wasn't merely a suggestion, it was a demand, a direct challenge to the nation's brightest engineers and scientists to conjure a miracle out of thin air and seawater. The Prime Minister's imagination had birthed the seed of the most ambitious engineering project of the war. The immediate reaction was a mixture of awe and incredulity. To dismantle the very concept of a static port with its deep water channels, vast quays and protected basins, and then rebuild it as a modular mobile entity, designed to withstand the fury of the English Channel and the unpredictable nature of an invasion beach, seemed an undertaking of near mythological proportion. Yet the gravity of the invasion, the stakes for which the Western Allies were preparing, reread the impossible and absolute necessity. The task fell to a diverse group of minds, pooling expertise from disparate fields. Among them was Professor J. D. Bernal, a brilliant polymath and crystallographer whose unconventional thinking perfectly matched the radical demands of the project. Working alongside him was Brigadier Bruce White, a seasoned military engineer with a pragmatic understanding of construction and logistics. Together they began to wrestle with the fundamental questions. How do you create calm water where none exists? How do you provide a stable platform for offloading tanks and trucks from ocean-going vessels onto a soft beach? How do you build structures of immense size and weight, then transport them hundreds of miles across a hostile sea? The answer lay in modularity and redundancy. The solution began to crystallize into distinct, interdependent components. First, there would be massive, hollow concrete structures designed to be towed across the channel and then deliberately scuttled to form protective breakwaters, creating the essential sheltered water that Churchill had demanded. These would be enormous, capable of absorbing the force of the Atlantic swells, creating calm pools where ships could safely anchor and unload. Next came the landing stages themselves. These were conceived as vast, floating pierheads, substantial enough to allow multiple ships to berth simultaneously, equipped with cranes and ramps. But these pierheads alone were useless without a link to the shore. This crucial connection would be provided by an articulated system of floating roadways, essentially bridges that could flex and adapt to the rise and fall of the tide, stretching from the floating pierheads all the way to the beaches. These roadways would be supported by a series of buoyant pontoons, allowing them to remain afloat even as the terrain beneath them varied. The very scale of the components, from the hundreds of thousands of tons of concrete required for the breakwaters to the miles of floating roadway, mandated an unprecedented manufacturing effort. Construction sites sprang up across Britain, veiled in secrecy, their workers often unaware of the true purpose of the monstrous concrete shapes taking form. Scientists, engineers, and naval architects worked feverishly, conducting experiments in laboratories and testing models in obscure Scottish lochs, refining designs, calculating stresses, and learning to predict the unpredictable behavior of such structures in open water. Every aspect, from the anchorage systems to the strength of the connecting pins, had to be meticulously engineered for a single, terrifyingly precise purpose. The initial vision, born in a war room, was slowly, painstakingly being translated into blueprints and prototypes, taking its first concrete steps towards an astonishing reality. February 1943, in a hushed design office deep within the Admiralty in London, the true scale of the Mulberry project began to emerge, not just as an audacious concept, but as a meticulously fragmented jigsaw of engineering marvels. The blueprints for each component, initially scrawled ideas, now took on precise dimensions, material specifications, and intricate operational instructions. Every part of this colossal enterprise presented a unique, often unprecedented engineering riddle that demanded radical solutions. At the heart of the design were the Phoenix breakwaters. These were to be the colossal walls of the artificial harbor, immense concrete caissons, each a hollow, impregnable fort of reinforced cement and steel. Imagine building structures the size of multi-story buildings, some towering over 60 feet high and weighing 6,000 tons, designed not to float indefinitely, but to be deliberately sunk with controlled precision. Their walls, often several feet thick, were engineered to withstand the furious battering of Atlantic gales, yet they had to be light enough to be towed across the channel. The internal compartments, designed for controlled flooding, were a testament to hydroengineering, allowing these titans to settle gently onto the seabed, forming an impenetrable barrier against the powerful currents and waves. It was a delicate balance of immense weight for stability and sufficient buoyancy for transit, a paradox resolved by brilliant, persistent calculation. Each Phoenix had to be a fortress of concrete, yet also a manageable vessel for its journey. Then came the whale roadways, incredible steel bridges, designed to float above the waves, connecting the Phoenix breakwaters to the shore and extend finger-like jetties into the heart of the harbor. These weren't static structures, they were dynamic. Each whale unit, often 80 feet long, was a marvel of articulated engineering, linked by massive hinge pins that allowed them to flex and undulate with the unforgiving channel tides. The challenge wasn't just in their strength, but in their flexibility, in ensuring that lorries laden with vital supplies could drive across them even as the sea heaved and fell beneath. The material science alone was groundbreaking, demanding new standards for steel strength and fatigue resistance in a constantly moving saltwater environment, capable of bearing tons of military traffic without buckling or failing. Supporting these whale roadways were the beetles, floating pontoons, flat-topped steel platforms designed to bear the load of the roadway and keep it at the correct height relative to the water. These robust platforms had to be intrinsically stable, capable of riding the swells without capsizing or transferring undue stress to the whale sections. They were the unsung heroes of the floating road, each one meticulously designed to integrate seamlessly into the larger dynamic system, ensuring a continuous, stable passage for vehicles across the often turbulent English Channel. And finally, perhaps the most ingenious components of all, the spud piers. Imagine a pontoon, much like a beetle, but equipped with 4 enormous retractable steel legs, or spuds. Once positioned, these spuds could be lowered to the seabed, digging in like giant anchors. Then, using powerful winches and jacking mechanisms, the entire pontoon structure, complete with its section of whale roadway, could be raised above the waves, lifted clear of the rising and falling tides. This was critical. Without the spud piers, unloading ships would be at the mercy of the lunar cycle, limited to specific tidal windows. With them, a continuous flow of men and material was possible, creating a true all-tide pier. The precision required for these jacking mechanisms, the colossal forces they had to manage, and their resilience in an active marine environment were engineering feats unto themselves, demanding groundbreaking solutions for hydraulic power and structural integrity. Each of these elements, the phoenixes, whales, beetles, and spud piers, was a complex machine in its own right, requiring thousands of detailed drawings, countless stress tests, and entirely new manufacturing processes. Shipyards, steelworks, and concrete plants across Britain were secretly transformed, not to build ships or tanks, but to fabricate these monstrous, unprecedented components. The logistics of coordinating these disparate manufacturing hubs, ensuring standardization, and maintaining absolute secrecy added another layer of extraordinary difficulty to the task. Engineers worked round the clock, driven by the knowledge that failure wasn't an option. Every weld, every pour of concrete, every mechanical hinge was a step towards D-Day, a silent promise of support to the fighting men who would eventually storm the beaches of Normandy. The sheer audacity of believing these immense, fragmented pieces could be assembled into two fully operational harbors, towed across a hostile sea, and deployed under enemy fire, stretched the boundaries of what was thought humanly possible. Yet the blueprints were finalized, the models perfected, and the construction began, not with a fanfare, but with the quiet, determined hum of industry preparing for the impossible. The engineering of Mulberry was not just about concrete and steel. It was about vision, collaboration, and an unwavering commitment to solving a problem that had stumped military strategists for centuries. It demonstrated an extraordinary capacity for innovative problem-solving under extreme pressure, pushing the very limits of civil and marine engineering. The legacy of Mulberry lies not only in its pivotal role in the Allied victory, allowing the continuous flow of supplies that fueled the liberation of Europe, but also in the enduring lesson it offers that human ingenuity, when fused with relentless determination, can literally reshape the world. It stands as a testament to the belief that even the most daunting, seemingly impossible challenges can be overcome, one meticulously designed component at a time. Each piece a silent echo of the brilliant minds and tireless hands that forged victory from an ocean of uncertainty. November 1942, in a series of heavily guarded estuaries and coastal towns across southern England, the greatest engineering challenge of the war, perhaps of any war, began to take physical form. The abstract brilliance of the Mulberry concept now demanded an equally extraordinary feat of construction. A monumental undertaking shrouded in absolute secrecy, each colossal component a piece of a strategic jigsaw puzzle designed to unlock a continent. The scale of what was about to be built defied immediate comprehension. Imagine a prefabricated harbor, an entire port infrastructure, engineered to float across a turbulent sea and assemble itself on an enemy shore. This wasn't a single structure, but a vast collection of specialized units, each designed for a specific purpose, built by an army of engineers and laborers across dozens of sites, all while maintaining the utmost operational security. At the heart of this audacious plan were the Phoenix Caissons, gargantuan concrete boxes, hollow within, some as tall as a 5-story building and weighing over 6,000 tons. These were the breakwaters, the foundation upon which the harbor would rest. Their construction began in vast, specially dug basins and converted dry docks along the Thames estuary, in Southampton and other coastal locations. Hundreds of thousands of tons of concrete, reinforced with steel, were poured around the clock. These colossal concrete leviathans were built in plain sight, yet concealed by a web of deception. Their true purpose was hidden under the guise of piers under construction or even air raid shelters, a cover story that, against all odds, largely held. Once completed, the basins were flooded and the Phoenix units with their cavernous interiors were floated out, their mass barely disturbing the water, to waiting moorings. Alongside the Phoenix, the arteries of the harbor took shape, the whale roadways. These were modular steel and concrete bridge sections designed with a revolutionary hinge system that allowed them to flex with the waves and tides, creating a stable connection from the landing beaches to the deeper water. Each whale section was 60 feet long, a marvel of robust yet flexible engineering. Interconnecting these roadways were the spud pierheads, large steel pontoon platforms equipped with massive retractable legs or spuds that could be lowered to the seabed, raising the platform above the water, providing a stable offloading point regardless of the tide. Then there were the bombardons, a ring of floating steel breakwaters, each resembling a giant cruciform pontoon. These were designed to dampen the formidable channel waves, creating a sheltered basin for the cargo ships to unload. Constructed from steel plates, these hollow behemoths were welded together in shipyards across the country, their peculiar shapes offering no obvious clue to their ultimate destination or function. The sheer volume of materials required was staggering. Over 1 million tons of concrete, 80,000 tons of steel, and countless cubic feet of timber. This monumental undertaking involved an unprecedented concentration of industrial effort. Shipyards accustomed to building vessels and construction companies used to erecting buildings now joined forces to fabricate a floating city. Engineers, architects, welders, crane operators, concrete workers, and even women who had stepped into vital roles left by men at the front worked tirelessly, often in punishing conditions, their collective labor a silent testament to the national will. Secrecy was a constant, almost tangible presence. Every component, every assembly site, every worker was enveloped in a shroud of secrecy. Code names replaced real names for every part of the project. Maps were meticulously faked, and disinformation campaigns were launched to mislead German reconnaissance. The enormous structures, some visible from miles away, were often disguised with camouflage netting or presented as conventional coastal defenses. The meticulous coordination between dozens of separate manufacturing sites, stretching from Scotland to the south coast of England, was a logistical nightmare, yet it was executed with military precision. As the months ticked by, the British coastline became a sprawling, clandestine workshop. The Solent, the estuary of the River Thames, and other hidden inlets became gathering points for these enormous pieces of a strategic puzzle. The sight of these colossal, inert structures, many camouflaged or partially submerged, must have been a peculiar one for those few who knew their true purpose. They were silent sentinels, awaiting their moment, a testament to an unimaginable effort. Every weld, every concrete pour, every bolt tightened was a step closer to a day of liberation, forged not on battlefields but in the unseen, unsung workshops of a determined nation. The ultimate test of their design and construction, however, lay ahead, across the treacherous waters of the English Channel. June 7, 1944, dawn over the English Channel saw an unprecedented spectacle unfold. From various ports along England's south coast, a fleet like no other began its slow, deliberate journey across the treacherous 20-mile stretch to Normandy. Not battleships nor troop transports, but the silent sentinels now revealed in their gargantuan scale, immense concrete caissons weighing thousands of tons were nudged and towed by powerful tugboats. Alongside them, floating roadways, pierheads, and beetle piers, each a marvel of wartime ingenuity, formed an armada designed not for combat, but for creation. This was the moment the dream of a floating harbor began its voyage to war. The sea, often a formidable enemy, was now to be a temporary highway for these improbable structures, their low profiles cutting through the choppy waters, a testament to the sheer audacity of their conception. Every knot in the tow ropes held the weight of an invasion. Every slow churning propeller pushed against the immense drag of concrete and steel, carrying the very infrastructure of victory to a war-torn shore. The crossing was an exercise in patience and precision. For days, under the watchful eyes of Allied air cover, these components crawled eastward, hugging the coast of Normandy until they reached their designated sites, one off Omaha Beach, codenamed Mulberry A, and the other off Arromanches, Mulberry B. The journey itself was fraught with peril. German E-boats and U-boats, though diminished, still lurked, and the ever-present threat of mines made every mile a gamble. Yet remarkably, against all odds, the bulk of the components arrived. At Arromanches, the sinking began. Engineers, working under immense pressure, meticulously positioned the massive Phoenix caissons, flooding their internal compartments with seawater until they settled firmly on the seabed, creating vast protective breakwaters. Within days, the once open expanse of water began to transform, taking on the unmistakable shape of a functioning port. The next phase was a ballet of heavy machinery and human determination. The floating pierheads, known as spud pontoons, were anchored in position, rising and falling with the tide. From these, the floating roadways, christened whales, snaked their way to the shore, supported by the beetles, giant concrete floats. It was an astonishing feat of rapid construction. Within a week, the first ships, laden with vital supplies, could begin to offload directly onto the beaches through this man-made wonder. Tanks, jeeps, artillery, ammunition, medical supplies, and tens of thousands of troops poured through Mulberry Bay, bypassing the need to capture heavily defended existing ports. This was the lifeline of the invasion, an engineering miracle that allowed the Allied forces to consolidate their gains and push inland, sustaining an army of over 1 million men with the material they desperately needed. Then, just as the harbors were proving their indispensable value, nature intervened with brutal force. On June 19th, a ferocious gale, one of the worst in 40 years for that time of year, swept across the channel. For 3 days, hurricane-force winds and towering waves battered the nascent harbors. Mulberry A at Omaha Beach, exposed to the full fury of the storm, suffered catastrophic damage. Its breakwaters were shattered, its roadways torn apart, and its components scattered across the seabed. It was a heart-wrenching loss, a testament to the unforgiving power of the sea. The decision was made to abandon Mulberry A, salvaging what little could be saved to reinforce Mulberry B. Yet, at Arromanches, though damaged, the British-designed Mulberry B, partly sheltered by the bay, held firm. Repairs began immediately, and it continued its relentless work. From its inception in June to its eventual decommissioning in December 1944, Mulberry B, or Port Winston as it became known, handled over 2.5 million men, 500,000 vehicles, and 4 million tons of supplies. It was a monument to foresight and unwavering perseverance. The vision of a harbor sailing to war was born from the dire necessity of a global conflict. It was a gamble on an unprecedented scale, an audacious solution to an impossible problem. The Mulberry Harbors represented the pinnacle of wartime innovation, a testament to the collective genius and sheer will of thousands of engineers, workers, and sailors who dared to dream beyond the conventional. Their legacy yours not just in the scattered remains visible at low tide off Arromanches today, but in the very fabric of military logistics and engineering, proving that with ingenuity and determination, even the most formidable obstacles can be overcome. These concrete giants slowly towed across the channel were more than mere structures. They were the physical embodiment of hope, carrying the promise of liberation on their sturdy backs, forever linking the workshops of Britain to the battlefields of Normandy, and proving that sometimes the greatest battles are won not with bullets, but with blueprints. June 8, 1944, off the coast of Arromanches, Normandy. Just 2 days after the D-Day landings, the first colossal components of the Mulberry Harbors began to arrive, slowly towed into position across the treacherous channel waters. This was no simple task. The very act of bringing these massive, unwieldy structures through enemy-patrolled seas and volatile weather was an engineering feat in itself. Once on site, the real work began. A frantic race against time and the ever-present threat of German counterattack. The outer walls of the harbor, comprised of the immense concrete phoenix, caissons, were meticulously sunk into predetermined locations, forming vital breakwaters against the channel's relentless waves. Inside this protected zone, ingenious floating roadways, dubbed whales, were linked together, stretching from anchored pierheads to the very shore. These pierheads, known as spuds, were sophisticated platforms with adjustable legs, allowing them to rise and fall with the tides, ensuring a continuous link for vehicles and men no matter the water level. Simultaneously, a similar, though ultimately less successful, harbor, Mulberry A, was being assembled further west off Omaha Beach, destined for the American forces. The energy on the beaches and in the water was palpable. a beehive of activity as engineers, sailors, and construction crews worked around the clock, fueled by the knowledge that every bolt tightened, every section connected, brought liberation closer. Within days, the concrete and steel behemoths began to take shape, morphing from individual components into fully functioning ports. By mid-June, the two Mulberry Harbors were handling an astonishing volume of traffic. Mulberry B, specifically, became a pulsing artery, its wharves teeming with activity 24 hours a day. Through this marvel of improvisation, Allied forces poured into France, tanks, trucks, jeeps, artillery pieces, and mountains of ammunition, fuel, and supplies. Food, medical provisions, and reinforcements for the beleaguered front lines flowed ceaselessly from ship to shore. Without these artificial harbors, the buildup of men and material necessary to break out of the Normandy beachhead would have been impossible, or at the very least agonizingly slow and perilously vulnerable to German attack. The sheer audacity of the concept was matched only by the unwavering dedication of those who made it a reality, creating a lifeline across the Channel, directly connecting Britain's industrial might to the battlefields of France. Then, on June 19, 1944, the unpredictable fury of nature intervened. A savage, unseasonal gale, the worst storm to hit the Channel in 40 years, swept across the invasion beaches. For 3 days, hurricane-force winds and mountainous waves pounded the nascent harbors. The exposed components, designed for more typical summer conditions, buckled under the unprecedented assault. Mulberry A, positioned on the more exposed sands off Omaha Beach, bore the brunt of the storm's wrath. Its breakwaters were shattered, its floating roadways ripped apart, and dozens of ships sheltering within its supposed safety were driven aground or dashed against the remaining structures. The damage was catastrophic and irreparable. The American engineers watched in despair as their colossal effort dissolved before their eyes. Mulberry B, situated in the more sheltered cove of Arromanches, fared better, though it too suffered immense damage. Parts of its breakwater were breached, and some of its pierheads broke free, drifting perilously. Yet crucially, it held together. The decision was swiftly made to abandon the wrecked Mulberry A, salvaging what parts could be retrieved to reinforce and repair Mulberry B. This consolidation allowed the remaining British harbor, now colloquially known as Port Winston, to continue its vital function. For the next 10 months, Port Winston remained operational, a testament to its design and the incredible resilience of the engineers who rebuilt and maintained it under immense pressure. It facilitated the unloading of over 2.5 million men, 500,000 vehicles, and 4 million tons of supplies, playing an indispensable role in the Allied victory in Europe. The saga of the Mulberry Harbors, from their audacious conception to their dramatic struggle against the elements, stands as a profound testament to human ingenuity and perseverance in the face of daunting challenges. It revealed that even the most meticulously planned operations could be humbled by the sheer unpredictability of nature, yet it also showcased the extraordinary capacity of individuals to adapt, overcome, and ultimately triumph. These concrete giants slowly decaying on the shores of Arromanches are more than mere relics of war. They are enduring monuments to the power of collaboration, the courage of innovation, and the absolute necessity of logistical brilliance in the grand theater of conflict. They speak of a moment when the blueprints of minds became the foundations of liberation, forever linking the workshops of Britain to the battlefields of Normandy, a poignant reminder that sometimes the greatest battles are won, not with bullets, but with blueprints. Indeed, the audacious vision to construct entire harbors and float them across one of the most treacherous stretches of water on Earth was a testament to a particular brand of wartime ingenuity, one born of desperation, forged by necessity, and honed by an unyielding will to overcome every conceivable obstacle. This wasn't merely engineering, it was a conceptual leap, a defiance of geographical limitations that had plagued military strategists for centuries. The challenge was immense. How to land hundreds of thousands of men, millions of tons of supplies, and tens of thousands of vehicles onto a hostile shore without the benefit of a deep-water port, the very infrastructure the enemy would naturally death to the last man. The answer, conceived in the quiet, smoke-filled rooms of Whitehall and painstakingly reared into reality in the shipyards and factories across Britain, was to bring the port with them. The scale of this undertaking was breathtaking, from the massive Phoenix caissons weighing up to 6,000 tons each, which formed the breakwaters, to the intricate whale roadways supported by floating pontoons that stretched for miles to the shore. Every component was a masterpiece of design and rapid manufacturing. These were not theoretical drawings. They were functional, modular giants, meticulously engineered to withstand the fury of the English Channel and the German defenses alike. This was the ultimate expression of human ingenuity under pressure, demonstrating how a singular, shared vision could galvanize an entire nation's industrial and intellectual might towards a common, monumental goal. It was a gamble on an unprecedented scale, and it paid off spectacularly. But these concrete behemoths, these intricate steel and timber pathways, were not built in a vacuum. They were the product of immense human effort, driven by the collective understanding of the stakes involved. Every rivet hammered, every ton of concrete poured, every section floated into position represented countless hours of labor from men and women who understood that their work, however removed from the front lines, was directly contributing to the liberation of a continent. Their sweat and toil were inextricably linked to the sacrifice of the soldiers storming the beaches, those fighting house to house, mile by mile, through the hedgerows of Normandy. The Mulberry Harbors were not just infrastructure. They were a pledge, a promise made by the home front to those facing the enemy, ensuring that their bravery would not be in vain, that their advance would be sustained, that their victory would be logistically secured. The immense effort to design, construct, and deploy these artificial ports was itself an act of profound sacrifice, a demonstration that the entire Allied effort was united in its determination to reclaim freedom no matter the cost. Without the Mulberries, the D-Day landings, however heroic, might have faltered. The initial gains on the beaches could not have been exploited to the extent they were. The relentless flow of men and material, up to 7,000 tons a day through Mulberry Bay alone, was the lifeblood of the Allied advance. It allowed Montgomery's forces to press inland, Patton's Third Army to break out, and ultimately ensured the rapid liberation of France in the drive towards Germany. They were a strategic trump card, a brilliant improvisation that confounded German intelligence and shattered their defensive calculations. The enemy had expected a quick collapse of any beachhead due to lack of port facilities. The Allies, instead, built their own. This extraordinary feat of engineering redefined the very possibilities of amphibious warfare, proving that with enough ingenuity and resolve, even the most daunting geographical barriers could be overcome, shaping the victory not just on the battlefield, but in the very logistical support that made it possible. Today, as the tides lap against the weathered concrete blocks of Arrow-Manches, standing as silent sentinels against the Normandy sky, their story continues to resonate. They are not merely museum pieces, but active lessons in foresight, resilience, and the transformative power of human innovation. The legacy of the Mulberry Harbors extends far beyond the sands of June 1944. They taught engineers new methods for prefabrication, transportation of massive structures, and the immense power of coordinated large-scale projects. They stand as a powerful reminder that even in the darkest hours, when the conventional seems impossible, human creativity can forge a path to victory, transforming abstract ideas into concrete reality. They are a permanent testament to the collective genius of a nation at war, a symbol of what can be achieved when minds are united by a common, critical purpose. The humble British inventor, the thousands of workers, the military planners, the courageous soldiers, all played their part in a symphony of effort that shaped the course of history. The Mulberry Harbors may be slowly reclaimed by the sea, and the sands, their steel corroding, their concrete crumbling, but their indelible mark on the annals of human evil, on the very shape of Allied victory, and on the unerring spirit of ingenuity in the face of impossible odds will forever remain. They whisper across the decades, echoing a truth born of fire and steel, that freedom, when truly fought for, can be built brick by innovative brick and floated across the very ocean to its ultimate triumph.